Today we're going to talk about graphing the parent functions of sine and cosine. If you think back to Algebra 2, your parent functions are the most basic form of your functions without any transformation. So no stretching, no shrinking, no left, right, up or down movement. So for sine, our most basic function, our parent function, is just when we evaluate the sine of x. And this is going to graph all of our values for sine of x. For cosine, our parent function again is the most basic, so it is just when you have cosine of x. One thing you're going to learn with trig functions is that they are what's called periodic. So trig functions are periodic because they repeat over and over and over again. And every repetition, your interval, is called a period. Feel free to pause it to take a second to write it down if you need to. The reason that this happens, if you think back to when we were evaluating our trig functions, we can find the trig ratio for any angle ever. We just often had to subtract revolution. So for example, if I wanted the sine of 5 pi, you would subtract 2 pi so you could evaluate, but you could still get an answer for it. So our answers repeat over and over and over again, and that's what you're going to find with your functions here. Looking at these two graphs, you can just have a rough sketch in there is fine. One of the two is periodic and one is not. If you look at it, the one on the left is our one that is periodic because it repeats exactly over and over and over again. To find the period, you're looking for where your graph makes a full cycle through all of its values. So for example, if I pick this as my starting point at 0, 0, it goes through all of the values at 4. So my period is 4 units. To do this, you could actually pick any value you wanted. So for example, if I wanted to pick this low point to the next low point, that is still 4 units. Or you could pick your high point to your high point is still 4 units, no matter what your period is 4 units. This second graph is not periodic, and that is because it's not, while it has the same shape over and over, it is getting higher as it goes. So it does not have the exact same values, whereas here the maximum was 5 no matter what. The minimum was -1 no matter what. It didn't get taller or shorter. This one, since it is growing, is not periodic. For your parent function of sine, we already talked about that we are going to graph f of x equals the sine of x. And we are going to plug in different angle measures to evaluate them. Whenever you graph these for me, you are always going to graph it kind of the same way, and we'll talk a lot about that in here. But we're going to plug in one period of the function. Your period here, where your graph starts repeating again, is after you complete one revolution. So we are only going to get values up to 1 revolution, which means I'm going to start at 0, and 1 revolution is when I get to 2 pi. We are going to plug in 5 values every time. You'll need this extra dash later, but not right now. For our 5 values, you could technically plug in whatever you want. Our easy ones are going to be our quadrantals because those give us pretty numbers that we can actually plot. So our quadrantal values, we can plug in our pi over 2, we're going to plot pi, and we're going to plot 3 pi over 2. Okay, if you think back to every time you were given a parent function back in Algebra 2, your teacher always made you make an actual x, y table. So I'm going to make that, and we're plugging in 0, pi over 2, pi, and I'm going to give myself an extra one for my other ones. We're going to plug in 3 pi over 2 and 2 pi. For these values, we are actually plugging in the angle and evaluating it. So this is where you're thinking about your ordered pairs. So for 0, we are evaluating the sine of 0. When you're doing that, your ordered pair is 1, 0. Sine is your opposite of our hypotenuse, which is your y value, and my y value is 0. Take a second to evaluate all of these. So again, you're figuring out what sine of pi over 2 is. Sine of pi, sine of 3 pi over 2, sine of 2 pi. Pause the video and then I'll fill in the answers with you. Now you should have all of them completed. Sine of pi over 2 should give you a value of 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And sine of 2 pi goes back to 0. When we go to plot these then, at 0, my maximum is 1, my minimum is 1. This y equals is your midline, so I'm just going to keep it as a 0. pi over 2, we're up at 1. Pi, we're back at 0. 3 pi over 2, we're at -1. And 2 pi, we're here. So my graph, and I apologize, this isn't going to be as pretty as if I could write on the board, makes this kind of S-curve. Okay. What I'm going to show you next then, if you go to Desmos, we can graph sine of x. And our points that we plotted are here. We have 0, 0, pi over 2, 1, 0, pi 0, 3 pi over 2, -1, and 2 pi. So this is the period that we plotted. However, you will notice my graph keeps going and going and going, and that's where your periodic function comes in. If I zoom out, it goes forever and ever and ever in both directions. Again, you are always only going to graph me one period, but know that your graph keeps going, and that's kind of what we're going to emphasize in a minute today. Okay. Now that you have that, we're going to do the same thing for cosine. So I do want you to go ahead and pause the video. You're going to plug in all your values. Same exact thing for cosine this time, but we're still going to use 2 pi, 3 pi over 2, pi, pi over 2, and 0. So go ahead and make your t-chart, evaluate those numbers, and then unpause it and we'll fill it in together. Okay, you should have had this pause so that you could fill it all in. When you plug in cosine of 0, when you plug in 0 and you do cosine of 0, you should get 1. Pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1. When I plot these points, it's going to make a very similar curve to sine. However, it is going to be shifted over. Okay, it is important that at the top you curve it back down because you shouldn't imply that this is going to keep going up and up and up. But this is what your parent function for cosine looks like. Again, we're going to take a second to go to Desmos and show you the entirety of the graph. So if we go to Desmos and graph y equals cosine of x, again, we graphed this first period. So 0, 1, pi over 2, 0, pi -1, 3 pi over 2, and 2 pi. This is the portion you will graph for me. However, it is important to recognize that this goes on forever and ever and ever in both directions. So if I zoom out, it just keeps repeating itself. Sine and cosine graphs are extremely similar. They're just basically a shifted, horizontally translated version of each other. Okay, so they will look similar, but you'll have different specific values at each point. Okay, what I have here then is just a chart that sometimes people like to have to help them remember all the little details. So you can make this in your notes and pause it, and then I will talk about this to make sure you know everything it's talking about. So pause it, write this down, and then we'll talk about it. Okay, so your period for both functions is 2 pi, because that's how long it takes to repeat. Again, that has to do with your 1 revolution. Your domain for each is your x values that you are allowed to plug in. Everything from -infinity to +infinity works. You can plug in anything you want to the function. However, your range is from -1 to 1 because you can't get anything out. Okay, your symmetry deals with how you could reflect it or rotate it and it would map to each other. Your x-intercepts are your zeros. So where it is hitting the x-axis. When you do this, so what this means, this x equals k pi, is that it is things that are coterminal with either pi or 2 pi or 0. Okay, it is a whole number times pi. Whereas your x equals pi over 2, this is just telling you that it is a fractional number when it is cosine. So all your x-intercepts for cosine happen when you have something over 2, assuming it is your parent function. For sine, your y-intercept is at 0, and your cosine it's at 1. They do not have asymptotes. That will come in with tangent and cotangent and your other reciprocal functions. For maxes and mins, again, your graph keeps going up and down over and over and over again. Your maximum for both happens at y equals 1. When it is a sine function, it happens with anything that is coterminal with pi over 2. With cosine, your maximum will happen anywhere that is coterminal with 0 or 2 pi. So again, here it says any k pi, so a whole number times pi, where your k is even. But as long as it's coterminal with 2 pi or 0, you're good. For a minimum value, again, they're both minimums at -1. For sine, you will get minimums with anything coterminal with 3 pi over 2. And for cosine, you'll get minimums anything coterminal with pi. Okay? You do not necessarily have to memorize this chart. Personally, I memorized the graphs and what they look like. So for example, this graph tells me that at all my whole number pi's for sine, I will have an intercept, because at all my whole numbers for pi, I have an intercept with my sine graph. My pi over 2 is a maximum, so that tells me everything coterminal with pi over 2 will be a maximum. 3 pi over 2 is a minimum, so everything coterminal with 3 pi over 2 is a minimum for our sine function. So I don't memorize the chart personally, I memorize the graph, but it is whatever makes the most sense to you. Again, you can do the same thing with cosine. So my maximums are at 0 and 2 pi, so anything coterminal with these will be maximums. Minimum is at pi, so again, anything coterminal with pi will be a minimum. And then pi over 2 and 3 pi over 2 are your zeros, so anything over a 2 will be a 0. But make sure you are familiar with these characteristics in one way or the other, whether from this chart or from looking at the graphs. One thing that's going to come in handy for is if I give you a problem like this and just say, hey, what is the value of sine of 32 pi, without having to do all the math like we've been doing so far. So go ahead and write this down. For doing exact values, you guys already know how to do this. We could absolutely subtract 2 pi from this a whole bunch of times, then figure out what your ordered pair is and actually plot it. But your graphs can help you do this more quickly. If you look at your chart or your graph, these are sine. I'm going to flip back to the chart real quick. It is a whole number pi. If you notice, sine of 32 pi. On my chart, it tells me that anything that's a whole number pi is a 0. If you look at your graph, anything that's coterminal with the whole pi value is a 0. So without even knowing the ordered pairs, I know that the sine of 32 pi is 0. The nice thing here, you can do the exact same thing with -14 pi. It is a whole number, that means this has to be 0. Again, we could add 2 pi a whole bunch of times, get a coterminal, and go from there, but this is a little bit quicker as long as you know your graphs. I will say with sine, it's a little more complicated, so you cannot necessarily tell right off the bat what this is coterminal with, so you are going to have to find your coterminal. So if I have 13 pi over 2, to figure out, again, let me flip back to the chart, whether that is coterminal with pi over 2 or 3 pi over 2, I do need to subtract revolutions and get back to that. So if I subtract revolutions, you're subtracting in terms of 2 pi, which means I gotta make this a 4. So 13 minus 2 minus another 2. You're actually going to do 3 of these. So you're subtracting revolutions. Tells me that 13 pi over 2 is coterminal with pi over 2. Once you know that, again, you can go to your graph or your chart. Anything coterminal with pi over 2 is a local maximum, so y equals 1. Go ahead and do this one. Find me what the coterminal for this by subtracting 4 pi over 2. When you subtract all your revolutions, you should get that 27 pi over 2 is coterminal with 3 pi over 2. Sine of 3 pi over 2 is a minimum, so it is -1. So again, we're just evaluating, but you can use your graphs to make it a little bit quicker. Write these down and try the same thing. Okay. Pause this if you need to, but otherwise I'll keep going. Cosine of 32 pi, if we flip back to our chart, whole number pi's, we do have to figure out whether it is an even number or an odd. Since 32 is even, that means this is a local maximum. So cosine of 32 pi is 1. Again, same thing here. This is an even number of pi's, so this is still a local maximum, so it's 1. cosine is actually way easier with your fractions, because if you look at your chart, anything that is fractional is an intercept. It is a 0. So cosine's fractions should always be at 0 if it is your parent function. So both of these just equal 0. The goal of this here is getting faster at figuring out what your values are for your quadrantals by noticing the patterns in your graph or in your chart. You can still do them like we have been doing of writing out your ordered pair and going from there with your quadrantal process, but this can get way quicker as you're working them through. What we're going to do next then to help practice that even more is evaluating a sine function on a given interval. So we are not moving it. However, instead of wanting to know just the first period, I want to know the specific region. So go ahead and write this down and then we'll start talking about it. Okay. With this is why I have five tick marks here. So I'm going to put 3 pi over 2 on my first one, since that is my first number. I'll put 7 pi over 2 on my last one. And then we're going to fill in these other numbers. 3 pi over 2, again, so if you look back to our graphs, all of our ones so far have been pi over 2 apart. So pi over 2 larger than 3 pi over 2 is 2 pi. If you do 2 pi plus pi over 2, that is 5 pi over 2. And then 5 pi over 2 plus pi over 2 gives me 6 pi over 2, which is 3 pi. Okay, so again, they're pi over 2 apart, so you're just adding pi over 2 each time to get the tick marks. Then we're using our chart or our knowledge of the graph to go from there. Since this is a sine function, your whole number pi's are your intercepts. So I immediately know without doing anything else that those should be zeros. However, now we have to figure out if it comes down and goes back up, or if it starts at the bottom and it's upside down. Again, this will be a portion of the sine function, just not the first period, so it should have the same values. Okay, to me, the easiest one to look at is this 3 pi over 2, because it is on our chart. We have in our information and in our first graph that 3 pi over 2 should be a minimum value. Following the pattern of the graph, since I know it's going to be my sine function all the way through, if this is a minimum, then 5 pi over 2 has to be a maximum. The other way you can check that is 5 pi over 2 is coterminal. If I subtract 2 pi, it is coterminal with pi over 2. Okay, but again, you can just notice the pattern as well. 7 pi over 2 is coterminal with 3 pi over 2, but it is also following the pattern and knowing that after my maximum, I'm going to come back down to a minimum. And that's my function. Again, it is our sine graph. It is just a different region. What I'm going to do is pull up the whole graph again and show you what we just found. So y equals sine of x. And we're going to zoom in. So our first point was 3 pi over 2. And we graphed this portion. So it is just a continuation of our graph, but I just wanted to know, hey, what is this graph doing between 3 pi over 2 and 7 pi over 2? And these are the values we plugged in. Okay, we're going to try this one then. Plot it, give it a second to try it, and then unpause the video when you're ready to look at it together. So go ahead and pause this for now. Here I have negative values, so I'm going to put my negative 13 pi here. I'm going to put my negative 11 pi here. I do know that halfway between these two should be negative 12 pi. To get in here, you're doing half of way between these, so you can add pi over 2. Should be negative 25 pi over 2. And this should be negative 23 pi over 2. Again, to get that, you can do, say, negative 13 pi plus pi over 2. Again, you get a common denominator, so this is negative 26 pi plus pi over 2. This is over 2, I apologize, which is how I get the negative 25. You can do the same thing to get this one. When you're graphing it, again, this is sine, so our whole numbers for pi should be my zeros. So I'm going to plot those right away. Then we have to know whether one of these is coterminal with pi over 2 or 3 pi over 2. Once you know one of them, you do technically know both of them, so you can figure out whichever one you want. What you can do is add 2 pi to either or both of these to figure it out. What I will tell you is that 23 pi over 2 is coterminal with pi over 2. And negative 25 pi over 2 is coterminal with 3 pi over 2. If you need a second to pause it and add 2 pi to this a bunch of times to figure that out, then go for it. But what that means is that my maximum is at this one, and my minimum is here at negative 25 pi over 2. And then here is the portion of my graph. Again, I'm going to go back and pull this up on Desmos. You're more than welcome to use this to help you. We got to keep going. 13 pi. Here we go. So, negative 13 pi, negative 25 pi over 2, 12 pi, 23 pi over 2, and negative 11 pi. So this is the portion that we graphed. Again, it goes on and on forever in both directions, but I wanted to know between these values, what does it look like? Okay, we're going to do the same thing now for cosine. If you think you can give it a try without me going through it first, then go ahead and do that. Otherwise, just keep the video playing. I'm going to steal the values that we used last time because we did already graph it over this region. So I do already know what these axes values are, but again, you're just making sure that they are pi over 2 apart, since that's how far apart my quadrantals are. With cosine, we know that our fractional ones are our zeros, so I can plot those right away. The other nice thing about cosine is our whole numbers, our intercepts, and whether it is even or odd tells you whether it's a max or a min. So cosine of 2 pi is a positive 1 because the 2 is even. Cosine of 3 pi is a negative 1 because it's odd. Again, this 3 pi is coterminal with pi. Then I can graph this. Whoopsies. Again, this is the same idea as what we've been doing with sine, but now it's just with cosine. What I'm going to do is show you the graph over here now. And again, we graphed, there's 3 pi over 2, from 3 pi over 2 to 7 pi over 2, and this is exactly what our graph looks like. Again, cosine goes on forever and ever. I asked for one period, and I specifically said this period here, so that's why our graph is just this region. Okay, the last one I'm going to have you do is this one. So again, start it, pause it. This should say pi right here. And then when you are ready, we can talk about it together, but pause the video until you are ready. Okay. Plugging these values on my axes, I'm going from negative 13 pi over 2 to negative 9 pi over 2. If I do negative 13 pi over 2 plus pi over 2, you're at negative 6 pi. If you do negative 6 pi plus pi over 2, you're at negative 11 pi over 2. And then negative 11 pi over 2 plus pi over 2, you're at negative 5 pi over 2. Going back to our attributes for cosine, we do know that the fractional ones for your quadrantals are your zeros. So I can already plot those 3 right away. Your whole numbers give you your max and your min. Even ones give you a maximum. Odd ones give you a minimum, again, because your evens are coterminal with 0 or 2 pi. Your odds are coterminal with 1 pi. And we're going to graph it. And it should look like this. Again, I'm going to go ahead and show you the graph so you can see what's actually happening. This time again, I've just asked for a different portion. There's my negative 5 pi, 9 pi over 2. There we go. Negative 9 pi over 2, negative 11, negative 6, and negative 13. Feel free to use Desmos to help you out like that because you can double check every bit of your homework. All you are doing is graphing your parent functions, just different regions depending upon what I ask for. We will not start moving your graphs until next time. This video is going to be put on YouTube and on Canvas so that you can access it whenever you may need to. You have the rest of your time today then to work on your homework.